lights, so hopefully the pictures will show up better. And hopefully the projector won't give out. But thank you all for coming today. I didn't realize this many people were interested in stone tools. But the research I'm presenting today picks up where my MA thesis left off. And I hope to include most of the issues I bring up today in my dissertation. My interest in the trade in stone materials used for groundstone tools developed as I studied the geological makeup of the groundstone tools for my thesis. I found it, and am still finding it, quite challenging to determine the source of all the types of rocks I encountered. And what contributed to my frustration was not finding much geological information in the literature on groundstone tools, about which there is very little, well, not very little, but relatively little to begin with, compared to other types of material culture. Although trade in obsidian has been relatively well addressed in the archaeological literature, and particular types of stone tools, such as Neolithic hand axes, or particular types of stones such as andesite from the island of Egina, although those have been addressed, the general trend is for those who publish groundstone tools to provide minimal geological information and synthetic information on groundstone tool use. My goal today is to demonstrate why groundstone tools are not to be taken for granted, and to demonstrate the various types of information that we can glean from them by asking the right questions. So first, I will provide a bit of background information to the topic and the site of Mitru, which I am using as a case study. Then I will compare the andesite tools from Mitru to the andesite tools from the site of Medea and the Argolid. I will also discuss sandstone tools from Mitru, and conclude by addressing some of the societal implications that arise from this research. So to start off with, what are groundstone tools? Well, as the name indicates, they are tools that have been ground down to an ideal shape and size for use by using a harder rock. They're made from many different types of stone. In the back, can you read the text?
Mm-hmm. Yeah.
Okay. They are made from almost any type of stone you could imagine. Sandstone, marble, limestone, basalt, andesite, gabbro, quartzite, schist, granite, and serpentinite, and etc. And in fact, I have seen all of these materials represented at Mitru. Since prehistoric people had use for stones of varying textures and hardness, groundstone tools can be made from any kind of rock. And what are they used for? They are used to make food processing tools, like mortars, pestles, grinding stones or manos, millstones or matates, as they're known, I guess, in the New World. And contrast groundstone tools with chipped stone tools, which primarily come from chert and obsidian. The cryptocrystalline texture of chert and the glossy texture of obsidian allow for sharp edges to be produced when the rock is fractured. And the island of Milos in the Cyclades was the primary source for obsidian in Greece, and it was very widespread. Chert, on the other hand, is readily available almost anywhere in Greece. Literally, operational sequence, Chaine Operatoire is the step-by-step analysis of all the steps involved in the production of a stone tool. Catherine Perles defines it as the succession of mental operations and technical gestures in order to satisfy a need, immediate or not, according to a pre-existing project. And this definition reflects the early sociocultural conceptualization of Chaine Operatoire, when the term was used to emphasize the changing brain of Homo sapiens and their ability to remember the steps in the manufacture of a product and their long-term planning. The term is now primarily associated with the study of chipped stone tools, as Frédéric Sellez definition more reflects, and he says, Chaine Operatoire aims to describe and understand all cultural transformations that a specific raw material had to go through. It's a chronological segmentation of actions and mental processes required in the manufacture of an artifact and in its maintenance into the technical system of a prehistoric group. The initial stage of the chain is raw material procurement, and the final stage is the discard of the artifact. So the important point here is that people work with a mental template for how to make and subsequently use a groundstone tool, or a stone tool. And I think it's safe to apply this model to groundstone tools. For now, I want to focus on the first part of the sequence, the procurement of materials and their trade. In order to understand in what state materials were originally used or traded, it helps to compare the similarity of tools made from imported stones across a site. It was my former advisor at the University of Tennessee who first put the idea into my head to morphologically compare these imported stone tools to determine in what condition they might have been shipped. Pondering this for a while, it made sense to me to compare the dimensions, the length, width, and thickness, and overall shape. Kathy Costin, in her 1991 article, explains how standardization is generally the result of craft specialization or large-scale production for various cost-saving factors. And in their 2001 article, Britt Hartenberger and Curtis Runnels applied this thinking to the study of chipstone tools from Lerna and make a case for the standardization of blades to be a sign of craft specialization in the early Helladic period. In short, if groundstone tools had been mass-produced and then traded, one would expect that they would all roughly be the same size and shape. Furthermore, if stone tools are manufactured to be traded en masse, one would also expect this to be the work of a specialist or two. So Mitru, which is my case study, lies on the Yubian Gulf, a major trade route in prehistory. It was continuously occupied from 2400 to 900 BC, even during the late Helladic 3C phase and the early Iron Age, a time when many sites throughout Greece were abandoned. Unfortunately, there has been little excavated dating to the Middle Helladic period, roughly 2000 to 1700 BC, and the Palatial period, 1400 to 1200 BC. And although it was not a large settlement, it did have moments of prosperity. For example, during the pre-Palatial or shaft grave period, when a local elite arrives on the scene. And in my master's thesis, I found that roughly 55% of the groundstone tools I studied were made from non-local materials. And I should add that the geology of Mitru consists primarily of limestone and serpentinite. Today, Mitru is a tidal islet, roughly 300 meters long by 180 meters wide. And this is the modern town of Trigana. And obviously this is the Euboean Gulf here, and that's Euboea in the background. I chose to study andesite because it is, to my knowledge, the farthest imported material, and because it was widely circulated on the Greek mainland. Aegina is some 225 kilometers from Mitru, so you see Aegina down here, and if you go this distance, it's roughly 225 kilometers. Unfortunately, there are only 7 stone tools from Mitru, or at Mitru from Aegina, one of which is dacite, which is compositionally similar to andesite but contains more quartz. And 6 of the 7 stone tools are saddle querns or fragments of saddle querns, tools upon which various grains would have been ground. And although this is a rather small number, they are useful for establishing the diversity of andesite tools. These querns range in date from late Helladic 2A to late Helladic 3B late, which is the end of the Palatial period. Although the earliest evidence of stone importation from Aegina is during late Helladic 2A, or 1600 to 1490 BC, the importation of Aeginetine pottery had begun already in Middle Helladic 2 early, circa 1900 BC. And this delay of 3 centuries is perhaps due to the preservation or excavation bias. As I said earlier, relatively little is known about Mitru during the Middle Helladic period. And here is a comparison of andesite from Egina. Unfortunately, the text went down there. Compared to the andesite tools from Mitru, and these are at varying magnifications. So, for example, this is 20 times magnification. That's 42 times magnification. There is a coin for scale, and that's not much bigger than that. And I included this picture to show what a fresh surface would look like. And this is the only non-saddle quern that's made from andesite at Mitru. That is a grinding stone. The varying degree of preservation at Mitru saddle querns makes it difficult to precisely compare them. The length for those whose total lengths are preserved varies from 30.1 to 35 centimeters, not a significant difference. The width for those whose total widths are preserved varies from 18.9 to 27.1 centimeters, more of a significant difference. Even these two, these bottom two right here, which are more or less contemporaneous during late Helladic 3B2, have widths of 19.2 centimeters and 27.2 centimeters, respectively. The thickness varies, for these 6, the thickness varies from 4.6 to 8.8 centimeters, although these latter 4 have similar thicknesses. Basically, there is not enough evidence to suggest that the stone imports from Egina came in a standardized form. On the other hand, the site of Medea in the Argolid has much more evidence to suggest that andesite came from Egina in no particular form. Medea, being much closer to Egina than Mitru, predictably has more andesite tools. Medea is 85 to 100 kilometers by the shortest route, but it's longer. It's shorter by sea, but longer by land, and it is 100 to 145 kilometers going the long sea route, but the shorter land route. My selection of the site of Medea for comparison to Mitru may seem arbitrary. However, of the excavation publications I searched through, only Medea had stone tools that were definitively identified as andesite, measurements of the stone tools, drawings, and a large enough number for comparison. From the excavations of the lower terraces, which includes the Mycenaean Megaron and Shrine at Medea from 1994 to 1997, 75 andesite tools were recovered. These excavated levels primarily date to late Helladic 3B to 3C, but what the stone tools lack in chronological breadth, they make up for in informative depth. And unfortunately, since I didn't have to scan the drawings, the picture didn't come out quite so nice. I selected 20 andesite millstones for suitable comparison. I chose millstones for the obvious comparison to the saddle querns from Mitru, and saddle querns are a specific kind of millstone. Furthermore, I only selected those millstones that were conclusively andesite millstones, as determined by the author, were of comparable size to those at Mitru, and were complete enough for comparison. The drawings on these 3 next slides come from the 2007 publication of the 1994 to 1997 excavations. The length, where it is fully preserved, of the millstones from Medea varies from 13.5 to 32 centimeters. The width varies from 10.5 to 24 centimeters. The height or thickness varies from 4 to 8.5. And these are more or less the same size, although they're not to scale, but they are to scale with one another, more or less. Not only are the sizes of the millstones quite varied, as one can see from the drawings, the shapes also vary considerably. In plan view, the main view in the drawings, the shapes range from elliptical, like this one, to ovate, to rectangular, and in transverse profile, which would be this view here. The dorsal surface, or the bottom, ranges from being convex, like this one, to convex with slight flattening, as in this one, to irregular, as in this guy right here. In longitudinal profile, so this drawing there, the dorsal surface dorsal surface ranges from being convex, like here, to being flat, as in this one, and being convex, flat. As does the ventral surface also varies from being concave to more or less flat. See, that's more or less flat. That's flat, flat. This overall variability in andesite millstones, even more so than at Mitru, leads me to believe that the andesite from Egina was traded in unworked form. To return to Mitru, sandstone tools also shed light on the issue of in what state materials were imported. I chose sandstone because it is the largest category of imported stone material at Mitru. I estimate 15 to 20% of all of the groundstone tools. And although there are several different kinds of sandstone at Mitru, none of which is local, the one most frequently used for groundstone tools is very fine to fine-grained, well sorted, and includes a high percentage of quartz. It's also well consolidated, so it's not likely to just fall apart if you're grinding something, which would not be ideal if you're grinding your food. This type of sandstone comes from the area of Kamnina, which is about 38 kilometers northwest of Mitru. This is Mitru down here, and this is the area of Kamnina. So 38 kilometers directly, or 45 to 50 kilometers this way. And I should also point out that in antiquity, the shoreline was much more inland than it is now, probably something along here. And again, here are some microscopic comparisons of the sandstone from Kamnina to the sandstone tools from Mitru, going from, this is at 18.5 to 52 times to 46 times, all the way up to 160 times magnification. And this is 30 times, all the way down to 215 times magnified. Of the 27 tools made from this sandstone, the majority, there were 15, that were used or are thought to have been used as grinding stones. So I'll focus on those. And 2 of them don't have pictures, unfortunately. Many of these tools were repurposed primarily as hammer stones or had multiple functions originally. The 2 main shapes for grinding stones appear to be discoidal and spheroidal. So this is discoidal, this is partly discoidal, that's spheroidal, that's spheroidal, that's partly discoidal. But other than the general shape, tools within these categories are not very similar in shape or dimensions. And for the discoidal tools, the length varies from 8.3 to 14.1 centimeters, while the thickness varies from 1.7 to 3.7 centimeters. Even the two saddle querns made from this sandstone show little similarity to one another. In short, the variability in the sandstone tools suggests multiple manufacturers. It seems more likely that these tools were shipped in raw form as small boulders or cobbles, and then shaped to desire by the user, rather than being shaped into a usable form by the trader, and then used as is by the purchaser or purchasers at Mitru. And I realize, probably the people in the front won't be able to read the text, but these graphs are based on my thesis research, and these are the stone tools from Mitru. This top left graph is the early Helladic 2B phase. This represents early Helladic 3 to middle Helladic 1. This is middle Helladic 2 to middle Helladic 3. This is late Helladic 1 to late Helladic 3A2 early, so the pre-palatial period or the shaft grave period. This is the palatial period, and this is the post-palatial period. And I include these to point out what happens from the pre-palatial period to the post-palatial period, from the pre-palatial period to the post-palatial period, and early Iron Age. During the pre-palatial period, at which time an elite emerges at Mitru, several new rock types are imported, and all the different colors the colors just represent different rock types, and the columns are different categories of stone tools. So these new rock types are imported presumably due to the increased trade networks of this period. Then during the palatial period, for which, like I said earlier, there is not a lot of evidence, other rock types become available, and there is less dependence on local materials. At this point, evidence indicates that Mitru was controlled by some palatial power, possibly Orchomenos or Thebes. And finally, during the post-palatial period, and into the early Iron Age, andesite is no longer imported from Egina, but the sandstone and other imported rock types are once again imported. So the purple represents andesite, while the yellow is sandstone. So you can see, and this purple up here is a different kind of, it's non-Egine andesite. So this is the earliest evidence of Egine andesite, and there isn't any more after the palatial period. And you can see the lack of sandstone tools in the palatial period. While the proveniencing of the imported types of stone, of which there are many, has been an ongoing project, it is illuminating the changing trade history of Mitru. If the inhabitants of Mitru were not free themselves to travel to the source of the sandstone, and were trading with another settlement, which settlement would that be? I don't know yet, but here is a map of the known Bronze Age sites in northern Low Greece. The Bronze Age sites are circled in red. And Komnena is right in here today, and the closest Bronze Age site would be Narika. But since Mitru also obtained basalt from this little island called Laconobesia up here, it is also possible that Canomedes was the one supplying both the basalt and the sandstone. And this chart is also based on my thesis research, but I present it to demonstrate the wide variety of materials people were willing to use. Again, the different colors represent different types of stone, and the columns are different categories of stone tools. As one can see, the sandstone in yellow was a very flexible, rather flexible material, while andesite was primarily reserved for saddle querns or quern slabs. Saddle querns. In the near future, I hope to work with a colleague to determine whether people use different types of stone to grind different types of grain. So to sum up, in the case of Egina, I think people had relatively unhindered access to the andesite on the island. After all, it is a fairly large island, and andesite is almost ubiquitous there. So it would be very difficult, I think, to control access to the whole island. The few scholars who have addressed the issue of andesite trade generally agree that it is likely that andesite was shipped as ballast on ships carrying other goods around the Aegean, making the andesite a kind of secondary product from Egina. And ballast is any material that adds weight and stability to the hull of a ship. So small boulders or cobbles of andesite could have been placed in the hull once the main cargo had been loaded to even out the weight. It is likely that with many sources of ideal rock types throughout Greece, people were generally free to come and go and take what they desired. At the same time, though, I think we need to understand more about the occasions when the existing trade networks broke down or when borders between rival polities became more enforced. And to return to the notion of Chaine Operatoire, people had a solid understanding of the properties of different types of rock. They had preference when certain rocks were available, but they were ready to use the local, readily available materials as well. And based on my thesis research, I do not believe that certain rocks carried more prestige, but this is an issue I would like to investigate more in my dissertation. So while I have perhaps raised more questions than I have answered, I hope I have at least demonstrated the kinds of questions future studies of groundstone tools can offer. In my dissertation, I aim to look at the use of groundstone tools at half a dozen sites in central Greece in order to understand the extent to which sites had similar industries, whether there was intra-site or inter-site craft specialization, which raw materials they shared, and how their industries changed over time. Thank you. Any questions, comments?
How did your approach differ from someone that was maybe in anthropology? I was looking at it from that side of the fence.
Well, actually, my background is in anthropology, and so I was, trying to include, anthropological theory. In fact, I used practice theory in my thesis to address, the notion of what is common practice between different households and so forth. Yeah.
Okay.
Does that?
So is your working hypothesis that people were not shipping tools and selling them? People were throwing rocks in the bottom of the hull and giving them away at the other end?
Well, I wouldn't say giving away. I think it was definitely, a valuable product. Well, I guess I'm probably biased, but I think, it's probably impossible to figure out how much one might have, would have been worth. But I think it was definitely that somebody, a merchant or whatever, would just go onto the island, grab a bunch of, rocks of workable size, and load them on the ship, and then sell them. But it wasn't the main trade. It was my point.
And you also think that it was, these were rocks that were being shipped by sea rather than over land, because why put the effort into shipping rocks over land?
Yeah, it's much more cost efficient to ship something by sea. And I was looking at a master's thesis by, I think his last name was Bao, B-A-O, in 2011, where he did a gradiometer survey of some harbor. I forget which harbor, but he found an anomaly which he interpreted as andesite ballast. So just a big pile of andesite that was got. I don't know if it was from a shipwreck or how it got at the bottom, but yeah.
Do you notice a difference in quality at all between like the palatial Medea versus like a secondary site like Mitru?
The quality of the stone?
Yeah, well, yeah, the stone or the make of the stone.
No. No. I think andesite is. I don't know. It's hard to tell like what would be a high quality. What a high
I
quality.
mean like
quartz would look
like the human, like making like the human construction of the stone.
Alright, so you're asking like, do the tools from Mitru or
Yeah.
Medea look better than
Yeah.
the other side?
Yeah.
I think that's totally a judgment call. I mean, well, first of all, they do come down to us quite fragmented or broken, and so it's hard to know exactly what the original shape would have been, but no is my short answer. I think that they're more or less comparable in quality. Yeah.
They're kind of bigger than I would have imagined. Can you just explain how they're manipulated?
Yeah, so your average saddle quarter would be about yay big by yay wide, and it's a saddle shaped sort of. So it has a curved bottom, and you just put it on the ground, sit on the ground, and take a grinding stone and just sort of grind your grain like that.
Right. So it's made for a lap or the ground in front of you.
Yeah.
Yeah.
Yeah, pretty much. Although at Mitru we do have this huge corn. We call it Cornzilla. I think it's like 15 kilograms, made from serpentinite. So you probably wouldn't want that in your lap. But yeah, I think just placing it on the ground and grinding your grain. And so there are one-handed grinders and two-handed grinders. Depending on, I guess, the volume of grain you're grinding and the size of the accompanying quern.
Do we have the pestles, for lack of a better word, as well?
So there's a bit of a distinction between grinding stone and grinding stones and querns and mortar and pestle. I think of mortars as being a smaller and more enclosed tool, and then the pestle is it's more elongated and you just work like one end, and so we don't have as many mortars and pestles as we do grinding stones and querns.
Okay.
Yeah.
I could see how fractured stone would be really easy to identify. For ground stone, how hard is it to identify whether that's a naturally occurring erosion or whether that's man-made?
You mean if you're just looking at the surface of a stone tool?
Yeah, like whether, is it a tool or is it just a rock?
Oh, okay, that's a fair question. Sometimes it is a challenge. And if it's an imported type of stone, then that's a dead giveaway that somebody brought that there and was using it for a specific purpose. But a lot of times we have cataloged materials at Mitru, and they are just rocks. So you have to look at, shape is the primary thing you look at. Is this a common shape for a stone tool? And if not, do you see some use where like some tiny striations on the surface?
Are they found in context? Like, are they found in a house site or in a, you know what I mean?
Yeah. So there is good contextual evidence from Mitru, and most of the time, we know which house and what time period the tool dates to. Yeah. But sometimes, it can be difficult to tell if something's a tool or not.
Are these same import types of stones, would they have been used in any kind of like building construction as well? Or are the tools they're importing from these sites specifically used in groundstone tools?
Yeah, so most of the buildings are made from mud brick, which to my knowledge doesn't require stone tools. You just make your brick out of mud and other elements. And yeah, so as far as I can tell, not used in the construction. However, we do have a couple of types, a couple of imported stones that I think were used architecturally, either maybe as a threshold or something, I don't know. Yeah, but yeah, nothing used for the actual construction of a building to my knowledge.
So if you're talking about the Chaine Operatoire, I'm wondering if there's evidence in Egina, I guess is where you're saying some of that andesite comes from. Did they just pick it up? I'm an idiot about stuff like this. Did they just pick it up off the ground? Did they mine it? How did it? There must have been an industry there if it was being exported.
Yeah, I think it is something you can pick up just off the ground. You don't have to quarry it. Yeah, it erodes like pretty easily, I guess. So yeah, you just find it lying around and in the right size.
So people would just walk around and pick it up and gather it?
I think so, yeah.
Okay.
I don't think anybody has found any Bronze Age quarries. Now, I haven't looked at the evidence for like the classical period when andesite was, and it became more of an industry of making, the big round millstones.
Yeah. Oh, right. The huge ones.
Like milling operations.
Yeah.
But yeah, as far as I know, and I think scholars agree that you could just go there and pick up what you wanted relatively easily.
And I have just a further question, which is, so you're arguing that there was some kind of low-level trade in this commodity, or that it was brought from one place to another, which
Yeah.
implies some kind of basic level trade. So is there another entity or element that would be a parallel to this kind of trade? In other words, for you to compare to. So I'm not thinking like pots, because pots are sort of high end, and we have a lot of evidence. Well, I don't even know what kind of evidence we have in the Bronze Age, but something that you could compare.
Like obsidian from Milos, I think would be the best
Right,
comparison.
I see what you're saying.
And that's found all over the Aegean. It's one of the very few sources of obsidian, I think, in East Europe. Andesite wasn't traded as much as obsidian, but yeah, that would be probably the closest thing to compare.
When you go to Australia, it's just covered in cast iron railings, and as I understand, it was all ballast that was brought.
Is there functionally a stone that's better than others that would result in preference for those materials, which would then lead to actual trade of that?
Yeah, so andesite, since it is a volcanic rock, is pretty hard, and it has a bit of a, the surface is really rough. Basalt, as I mentioned, is also another volcanic rock and has a porous surface. So those would be like ideal types for grinding grain upon. But people also use limestone, which is not a very hard rock, and I don't know how I don't know if that would like affect the taste. You can get some calcium carbonate in there, and that's why I'm keen on doing this study with my colleague to see if people were using different types of rock for different types of grain. But yeah, there is a definite preference. Any more questions or comments?
So they were grinding grain to make flour, to make bread or porridge, or what kind of grain and where does the grain come from and all this?
So this isn't my area of expertise. I should study up on it, but yeah, they, I wanna say rye and barley, and wheat. I think they were using they used several kinds of grains,
Mhm.
but I don't know, other than bread, if they were, what their diet
Uh-huh.
would have consisted of.
Well, they mentioned in the, Homeric poems, they talk about barley, so we know that they were eating barley or some,
Yeah. But yeah, I think it's all local food.
Mhm.
Hops, I guess.
Thank you very much.
Thank you.